In the last section, we learned the basics of logic. We also learned about truth tables and helping us organize data. In this section, we're going to continue to learn how to organize data using sets and Venn diagrams. So first, let's do some definitions. A set is a collection of items or things. Each item in a set is called a member or element of the set. A set consisting entirely of elements of another set is called a subset. Set notation is used to define the contents of a set. So set notation looks like these curly brackets. Sets are usually named using a capital letter and its elements are listed once inside a set of curly brackets. So let's look at some examples of these. Consider the set of all whole numbers between 1 and 10. What are the elements? Write the set in set notation. What are some examples of subsets? So if I were writing out this sample space using set notation, we would, or this entire set, I guess we haven't learned sample space yet, but if I was writing out this set, we can call it S, capital S. So if I was writing this out, we'd be listing out all the elements in there. So the elements that are in there, or the members, are whole numbers between 1 and 10. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then if we were talking about subsets, so subsets are just like, I like to call them like smaller little sets of this. So a subset could be, let's do capital J for Jessica for the name of it. So a subset would be, I don't know, just pick a few numbers to put in here. So 1, 4, and 7. This would be a subset. This entire set exists, all of those elements exist in the main set. Another subset we'll use W is 1, 2, 3, 4. Everything in W is also in this large set. So these W and J would be subsets of S. Another subset, we'll call this P, would be just the number 10. Again, all elements in 10, or all elements in P, which is just 10, is an element in the larger set. So P is a subset of S. Paul, Maria, Jatika, and June took a quiz. They got the following scores: 90, 77, 85, and 85. Let T be the set of test takers and S be the set of test scores. Write each set using set notation. So if T is the set of test takers, that's their name. So we have Paul, Maria, Jatika, and Jen. Now, if we want to write the test scores, and they asked us to call that S, that would be 90, 77, and 85. Now notice 85 happened twice, but I only wrote it in this set one time. And that's because we're just writing the elements or the members. So what are the values that these people could get? Well, they could get a 90, a 77, or an 85. I'm not saying 85 4 times. I'm just saying these are the outputs are 90, 77, and 85. So we don't repeat values because I've already said this is an element of the test scores. Okay, let's keep on going with some set notation and definitions. The universal set is the set containing every possible element of the described context. Every set is a subset of what we call the universal set. So the universal set is typically denoted using the U symbol. So when we were talking about whole numbers on the last slide, our universal set would be all numbers. There's the null set, and the null set is basically it's the set with nothing in it. So there is nothing in it, not even 0, there's nothing in it. And the way that we denote the null set is you can either use the squiggly brackets with nothing inside them, or you can use this symbol, which kind of looks like a 0 with a slash mark through it. So let's look at this. And you're probably wondering at this time, like, is it possible to even have a set with that has nothing in it? And so there's lots of examples of that. If I said this set of, if we had, let's see, well, let me give you a real life scenario. So it's like going to the grocery store to go buy your favorite foods and you realize you left your wallet at home. You end up walking away with an empty bag. So the set of items that you bought at the grocery store that day can be written as the empty set. So illustrate the set of TikTok accounts you follow that are coworkers with the implied universal set. So I'm going to show you guys how to do this using a Venn diagram. So this rectangle represents that universal set. And in this case, the universal set would be all TikTok accounts that I follow. So all TikTok accounts I follow. So there's our universal set. There's a subset, so there's a small group within all of the people I follow that are my, we'll call C, and let's let C equal the coworkers I follow. So this is how we can illustrate the set of TikTok's accounts that we follow that are coworkers. So that would be what's inside, it's a subset of that universal set. And the implied universal set, which would be all TikTok accounts I follow. Another subset of all TikTok accounts I follow could be my family. All right, suppose you go to the grocery store. Oh, we already talked about this one, but we're going to look at it again. Suppose you go to the grocery store to buy your favorite foods and you realize you left your wallet at home. You walk away with an empty bag. Illustrate the set of items you bought at the grocery store using set notation. So in this case, let's let G stand for that set. And we bought nothing at the grocery store because we forgot our wallet. So you can write it like this with those squiggly lines with nothing in them, or you can use that 0 with a slash mark for the, and that implies the empty set. Okay, let's continue with some more vocabulary. We're going to talk about intersection, union, and complement. The intersection of two sets contains only the elements that are in both sets. To be in the intersection of set A and set B, an element needs to be in both set A and set B. The union of two sets contains all the elements in either set or both. To be in the union of set A and B, an element must be contained in just set A, just set B, or the intersection of set A and B. So the intersection are the elements that are in both A and B, where the union includes those elements plus the elements that are just in A and the elements that are just in B. And finally, the complement of a set contains everything that is not in set A. To be the complement of set A, an element cannot be in set A, but it will be an element of the universal set. So typically when we notate a complement, we use the set and then we write the C up top to say that this is the complement of set A. So this was a lot of vocabulary. Let's actually put this into action with an example. So let's say I have these sets. Set A are the colors red, blue, yellow, green. Set B are the colors red, orange, and green. And set C are the colors red, orange, yellow, blue, purple. The universal set, so this means all the colors that are red, orange, yellow, blue, purple, and green. First question, determine the set A intersect B and write it in set notation. So for the intersection, we use this notation. It looks like an upside down U. So we would write A intersect B equals, and then using those squiggly brackets. So the intersection are the sets that have the elements in both. So what are repeats in both A and B? So it looks like red is in both A and B, and green are in both A and B, and that's it. So the intersection of sets A and set B are red and green. So those are the elements. Determine the set A union B and write it in set notation. So for union, we use a U symbol. So for the set, the union of A and B, so those are the elements that are in either set or both. So they have to be in either set A or set B or in both. So what I typically do when I write these out is I'll write all of the elements in A. So red, blue, yellow, green. So now I've listed all the elements in A that are also, and also the elements that are in A that are also in B. Now I need to see what I have left in B that I haven't notated yet. So I've said red, I've said green, what I have left is orange. So I'm listing out all the elements that are in either set A or set B or both. Determine this intersection of A complement and set C and write it in set notation. So that's going to look like A complement, and we're doing the intersection, so that's that upside down U, and set C. So we're finding an intersection means the elements that are in both set A and set B. So if we had to figure out, let's first figure out what A complement is. So A complement is going to be looking at set A in the union, and it's going to be all of the colors that are not in set A. So it's everything that's not in set A. So red is in set A, so that doesn't count. Orange. Orange is not in set A, so that is an element of the complement. Yellow is in set A. Blue is in set A. Purple is not in set A, so that's in the complement of A. Again, the complement is the values that are not in set A. And green is in set A. So A complement is just orange and purple. So if I was finding the intersection of A complement with C, let's see, so what values happen both in A complement and in C? Orange happens in both, so we'd write orange. And purple, does purple happen in C? Yep, it does. So the intersection of A and C is just orange and purple.